Hi everyone, I'm Cheryl. In this problem, we're given a position vector which is going to represent the path that an object moves as it's going through space. And we're asked to find the velocity vector, the speed, the acceleration vector, and then also the velocity and acceleration vectors when t equals 0. So let's begin with that velocity vector. To go from the position to the velocity, you find the derivative. So my velocity vector is going to be I minus j plus, now I can think of this as 9 minus t squared to the 1/2 power. So this will be 1/2 9 minus t squared to the negative 1/2 power times a minus 2t times my vector k. And I can simplify this by writing it as vector I minus vector j. And I notice that this 2 will cancel with this one. And I'm left with a minus t divided by the square root of 9 minus t squared times my vector k. All right, that's the velocity vector. The next thing I want to find is the speed. The speed is the norm of that velocity vector, which means I'm going to be taking the square root of the sum of the squares of each of those components. So my first component is a 1, so that's a 1 squared. The second component is a negative 1, so that's minus 1 squared. And the third component is minus t divided by the square root of 9 minus t squared. And again, I'm squaring that. So now I have some algebra to do. So I have the square root of 1 plus 1, so that will be a 2, plus t squared all over 9 minus t squared. And I can get a common denominator here of 9 minus t squared. And this will become 2 times the quantity 9 minus t squared plus t squared in my numerator. And that all reduces, I'll have an 18 minus 2t squared plus t squared, so that'll be a minus t squared in my numerator, and my denominator is 9 minus t squared. That gives me the speed. Okay, next is the acceleration vector. The acceleration vector, I know, is the derivative of the velocity vector. Okay. And I calculated the velocity vector already. Notice the first two components are just constants. So I'll have 0i minus 0j. But for the k component, I'm going to use the quotient rule. So I'll have the denominator, 9 minus t squared to the 1/2, times the derivative of the numerator, which is 1. And then I'll subtract the numerator, t, times the derivative of the denominator, which will be a 1/2, 9 minus t squared to the negative 1/2, times a minus 2t. That's all over the denominator squared, which is 9 minus t squared, and I still have my vector k. Okay, I notice I have some simplifying I can do here. For one thing, this 2 will again cancel with that 2. And I notice that I have two very large terms in my numerator. Both of them have a 9 minus t squared in them. And I'll factor out 9 minus t squared to the negative 1/2, because here's the positive 1/2, here's the negative 1/2. This is the smaller of the two. When I factor that out, in this first term, I'm left with a 9 minus t squared. And in the second piece, the 9 minus t squared to the negative 1/2 has been completely removed, but I'm left with a positive t squared. And that's still all over 9 minus t squared. And don't forget your vector k. All right, a little more simplifying. I've got 9 minus t squared plus t squared. This part in the square brackets just reduces to a 9. And this factor can be pulled into the denominator. So I have a minus 9 in my numerator, and in my denominator, I'll write this as 9 minus t squared raised to the 3 halves power. And it's all multiplied by my vector k. All right, so that's my acceleration vector. The next thing I want to do is find out what the velocity vector and acceleration vectors are when the parameter t equals 0. So I'll go back here and just plug 0 in for all the t values in my velocity function. So I have simply an I minus j minus 0 over the square root of 9 minus 0 squared times vector k. This constant is just a 0, so at t equals 0, my velocity vector is just I minus j. Okay, let's go and do the same thing for the acceleration. I calculated my acceleration vector to be minus 9 over the quantity 9 minus t squared to the 3 halves times vector k. Again, all I have to do is plug in 0 every time I see a t. So minus 9 all over 9 minus 0 squared to the 3 halves times my vector k. Well, in the numerator, I just have a minus 9. My denominator will be 9 to the 3 halves power. That's 27 times vector k. And I can do one more simplification step by writing that as minus 1/3 times vector k. I hope that was helpful. Thanks.